The universe has always been a source of wonder and mystery, captivating the minds of scientists and dreamers. But every now and then, a discovery shakes the foundations of our understanding, calling into question everything we thought we knew. Such a revelation recently emerged from the depths of space thanks to the James Webb Space Telescope, JWST. This revolutionary instrument has discovered 6 massive galaxies that appear to challenge established cosmological theories. What makes this discovery even more fascinating is the involvement of renowned physicist Michio Kaku, who confirmed that these findings could herald a new era in our understanding of the universe. Get ready to embark on a journey of discovery and its profound implications, challenging the very core of scientific thinking. With his outstanding contributions to the field of physics, Michio Kaku recently confirmed that the James Webb Space Telescope has discovered 6 massive galaxies that scientists previously thought did not exist. This research has the potential to open up new dimensions in our scientific understanding of the universe. This discovery is both exciting and revolutionary, challenging existing theories of galaxy formation and evolution. So it is important to keep an eye on these developments. The endorsement of such a prominent scientist highlights the importance of these findings. Michio Kaku is a remarkable figure in the field of science. A physicist of American and Japanese descent, he is considered an expert in classical experimental physics and quantum mechanics. Unlike some more conservative and skeptical scientists, Kaku was receptive to the surprising results of the James Webb Space Telescope mission. His willingness to embrace new discoveries and share them with the public underscores his commitment to advancing our understanding of the universe. We are delighted that this brilliant scientist has decided to break his silence and share publicly what is undeniable. The enthusiasm and almost amused tone of the renowned brilliant physicist is evident in his comments on the discovery made by the James Webb Space Telescope, saying that it was a highlight that piqued his interest. Join us as we explore the implications of Michio Kaku's discovery of these 6 massive galaxies. Kaku was a scientist who was always willing to consider new theories. Throughout his life, he demonstrated an openness to ideas that challenged the status quo, understanding that Einstein's equations of relativity and Newton's laws, while fundamental, were not enough to capture all the complexities of the universe. Kaku understood that the new telescope's findings had the potential to enrich the field of science. Although many of his colleagues could not accept this view, it caused anxiety and sleeplessness among Big Bang supporters and those who oppose quantum mechanics. However, this only made Kaku laugh. JWST revealed the discovery of 6 giant galaxies dating back to the early universe. Each of these galaxies contained more stars than our Milky Way, even though they did not form until 200 to 700 million years after the Big Bang. The team of astronomers who made the discovery are calling these extraordinary galaxies cosmic disruptors because, if confirmed, they would revolutionize our entire understanding of the universe. The implications of these findings are profound, suggesting that the early years of the universe were far more dynamic and complex than previously thought. Something is wrong here. The Big Bang Theory tells us that the universe was a catastrophe after the initial event. It took hundreds of thousands of years for the first solid objects to form, and hundreds of millions of years more for these objects to become dense enough to produce light. The formation of complex structures such as galaxies is thought to have occurred much later. Some of the newly discovered galaxies are larger than the Milky Way, and their enormous luminosity suggests that they are capable of forming hundreds of new stars every year. Whereas our galaxy forms stars only sporadically, it is not known exactly when the first galaxy formed. Researchers have not yet been able to determine this. The only thing that is certain is that initially there were probably only isolated stars or groups of stars that eventually merged together to form increasingly larger accretion regions until dwarf galaxies appeared. Small galaxies met other galaxies and gradually grew. According to previous theories, massive and highly organized galaxies could not have existed at that time, raising the question of whether the universe is much older than previously thought or whether complex arrangements of galaxies developed much earlier. This situation is difficult to accept for conservative science, which still has problems with this model, and some branches of physics refuse to accept this finding and question possible errors in the age calculation. Kaku is aware of this and says, "There are many examples of old and erroneous theories that stubbornly persist due to the prestige of some scientists. Many of these theories are only discredited when a key experiment shows that they are wrong. This is why, in all sciences, and especially in physics, the key word is that of the experimentalists who ensure the honesty of the theorists. In fact, on Earth, we know very little about the real beginning of the universe. And this quote from Kaku emphasizes the importance of continuous testing and confirmation in the scientific process. The Big Bang Theory was proposed in 1927 based on observations of the expansion of the universe. This data led to the conclusion that the universe originated from a single point and has been expanding ever since. At that time, it was difficult for people and scientists to imagine a universe with a beginning and an end. The idea of a universe that has always existed and is infinite in time and space is beyond human imagination. Even today, scientists are still trying to understand it. However, it is important to reconsider these probabilities. These new evidences are completely inconsistent with what researchers have built on the Big Bang Theory for decades. However, science has proven time and time again that reevaluation and openness to new ideas are an integral part of the scientific process, as is the confirmation of certain theories and observations. When Einstein was a child, it was believed that stars and planets were firmly fixed in the universe and that these specific structures occupied a definite space. However, we now know that everything in the universe is in motion. Planets orbit stars, stars move through their galaxies at hundreds of kilometers per second, and entire galaxies move rapidly through the universe, their fates not even predictable to us. This dynamic understanding of the universe challenges long-held beliefs and emphasizes the need for continued research and adjustment of scientific thinking. Today, scientists are challenged to accept uncomfortable truths and understand that theories are not absolute truths until they are rigorously tested or confirmed by precise observation. The idea of the Big Bang arose from the realization that galaxies are moving away from each other, and that this distance is proportional to their distance from Earth. This observation, known as Hubble's law, suggests that the universe is expanding. For a long time, things like the cosmic background radiation and the redshift of light from distant galaxies and other cosmic structures seem to support this theory. However, it is important to remember that in the past, people who believed that the Earth was flat and that the Sun revolved around us also had physical evidence for their hypothesis until a coincidence or technological improvement brought a clearer and more accurate picture. We are currently experiencing a similar situation. Scientists expected the new James Webb Space Telescope to confirm theories about the Big Bang, but they stumbled upon these 6 galaxies, something that seemed unlikely. This reminds us that science is constantly evolving, and that scientists must be open to new discoveries and rethink existing theories based on available evidence. These unexpected discoveries have challenged current understanding and prompted a re-evaluation of long-standing cosmological theories. Researchers use redshift as a tool to measure certain quantities in the study of the universe. Redshift, also known as the Doppler effect, refers to the change in the color of light as the light source and observer move relative to each other. To understand this, imagine that you are standing still and you see a car coming towards you. As the car moves towards you, you hear the engine noise getting louder. However, as the car passes you or moves away from you, the engine noise changes. Indeed, the engine noise changes as the car moves forward. The same thing happens with lights. As a light source, such as a distant star, gets closer to us, the light we perceive shifts toward bluer colors. On the other hand, as the light source moves away from us, the light shifts toward redder colors. This phenomenon is called redshift. Physicists convert redshift values into speeds and distances to measure them in space research. However, it is important to note that small errors in these measurements can have big consequences. The measurement techniques used to date are currently being revised. The latest evidence regarding our universe forces us to question whether they are really based on redshift errors or whether some scientists are simply denying the facts. This is a question that requires close analysis and careful consideration of the data and methods used in the study. The examination and re-evaluation of current measurement techniques highlights the evolving nature of scientific research. The study of our universe, with its vast spaces and complex celestial bodies, continues to fascinate and challenge scientists around the world. From the earliest theories of the universe to the latest discoveries made possible by cutting-edge technology, each discovery reshapes our understanding of the universe and pushes the boundaries of human knowledge. One of the deepest and most enduring questions in cosmology revolves around the origin and evolution of galaxies. Galaxies are cosmic cities of stars, gas, dust, and dark matter bound together by gravity. Understanding how galaxies form and evolve is crucial not only to unlocking the mysteries of our universe, but also to confirming or challenging existing theories such as the Big Bang Theory. The Big Bang Theory, proposed nearly a century ago, proposes that the universe originated from a singular, infinitely dense point and has been expanding ever since.